Just wait for a moment. Yes, my dear children, just all of you watch this screen carefully. All of you watch this screen carefully. In this PPT, we are going to discuss quadrilaterals. Exercise 8.1. In this exercise 8.1, sorry, I will start 8.1. By mistake, I presented 8.1, question number 1 to 8 to. Okay, just wait for a moment. Wait for a moment. Just wait for a moment. Are you able to watch the screen now?
No, sir.
Are you able to watch the screen? What is there on the screen?
Yes, sir.
Tell me. What is
Exercise
there?
8.1, question number 1, 2, and 3. 3 and 4.
Yes. So in this PPT, I'm going to explain. We are going to discuss the sums, question number 1, 2, 3, and 4 in this exercise 8.1. Are you ready to listen the class, my dear children? See this?
Yes, sir.
Yes. Question numbers 1, 2, 3, and 4. I will post this PPT also in the Google Classroom in the form of PDF. For your convenient, for your sake, I will post this PPT also in the Google Classroom. See this first page number 146, the textbook. If you have textbook, please open the textbook at page number 146. All of you open your textbook at page number 146. You will find question number 1. What is this question number 1? See here, question number 1. I am presenting the question also here. I wrote the question also here. See, what is the question here? The angles of quadrilateral are in the ratio 3:5:9:13. Find all the angles of the quadrilateral. This is the question. Here, the ratios of the angles were given. We had to find measurement of these 4 angles of the quadrilateral. Understood this point, my dear children? Understood this point? Understood this point or not? No response? Nobody is responding? Nobody is responding?
Yes, sir. Yes, understood.
Yes, tell me at least. Yes, sir. I understood, sir. But like this, I have doubts, sir. Please explain this point again. Like this, you have to ask your doubts. Understood? Right. Now come to the solution. We are going to find the angles of this quadrilateral. Okay. See here.
Sir, I'm able to see only the first.
Sorry?
Sir, I'm able to see only the first slide.
You are not
Yes.
able to?
Sir, I'm able to see only the first slide. I'm not able to see the first question.
Are you not able to see the first line? Page number
Sir,
146.
sir, your
Sir,
PPT
in
is
the
there only in the first slide, sir.
Sorry?
Sir, we are able to see only the first slide of your PPT.
Only first line.
Yes, sir, that quadrilateral exercise 8.1, that is only visible.
Okay, I will check. I will check this one. I will check this. First question, are you able to see the question number 1?
No, sir.
No?
Yes, sir.
Yeah, let me see. Let me see. Let me see this one. Now, are you able to see the screen?
No, sir.
No. Wait, just wait for a moment. Now, are you able to see the screen?
Yes, sir.
Okay, now? Is it okay now? What is there? Solution? Please read that solution, first line.
Let the common ratio between the angles be equal to x.
Yes. All of you able to see the screen now?
Yes, sir.
Yes. Now we go ahead. So first of all, we have taken the common ratio. The common ratio between the angles B, X. Now we know the properties of angle sum property of a quadrilateral. What is the angle sum property of a quadrilateral? Yes, we know that sum of the interior angles of a quadrilateral is equal to 360 degrees. This is nothing but angle sum property of a quadrilateral. Understood this second line? Understood this second line? In the solution, this is nothing but angle sum property of a quadrilateral. Okay, my children. Now, 3x plus 5x plus 9x plus 13x is equal to 360 degrees because the first angle is 3x. We have taken here first angle is 3 parts, second angle is 5 parts, third angle is 9 parts, and fourth angle is 13 parts. We have taken the common ratio between the angles is x. That is why we have taken the measurement of the first angle is 3x. Similarly, we have taken the measurement of the second angle is 5x. Similarly, the measurement of the third angle is 9x and the measurement of the fourth angle is 13x. Understood this point, my children? What are the angles of this property? 3x. What are the angles of this parallelogram? Quadrilateral. 3x is one angle, 5x is another angle, 9x is the third angle, and 13x is the fourth angle. So, by angle sum property, we can write this statement 3x plus 5x plus 9x plus 13x is equal to 360 degrees. Understood this step? Understood this step, my children? 9x, 3x plus 5x plus 9x plus 13x is equal to 360 degrees. Understood this step or not? Tell me.
Yes, sir. Is 360
Yes, sir.
degree. Yes,
From this equation, can you find x value? Can you find x value? Please take a pen and a rough paper. Please take a pen and a rough paper and tell me the value of x. Tell me the value of x. Please tell me the value of x. Solve this equation and tell me the value of x. Can you solve this equation for x? All of you take a pen and a paper and solve this equation.
Sir, x is equal to 12.
X is equal to 12. Okay, let us see whether we are getting x is equal to 12 or not. Okay. This implies 30x in LHS. In LHS, if you simplify the four terms, 3x plus 5x plus 9x plus 13x, because all these terms are like terms, we can add like terms. In algebra, you have learned that point. So by adding all these like terms, we get 30x in LHS is equal to 360 degrees. Okay, right. What is the next step? This implies x is equal to 360 degrees by 30. That is equal to 12 degrees. All of you got 12 degrees for x. Have you all got x value 12?
Yes,
Have
sir.
you all
12.
x is equal to
X equal
12?
to, yes, sir, 12.
Have you found the value of x by taking a pen and rough paper or simply watching the screen? You have to find the value of x by yourself. Okay. So here finally we got x value. Then we find four angles. We find four angles of this quadrilateral. Therefore, angles of the quadrilateral are 3x, that is the first angle. 3x means 3 into x. So 3 into 12 degrees, that is equal to 36 degrees. And second angle is 5x. 5x means 5 into x. What is x value here? We got 12 degrees. So 5 into 12 degrees, that is 60 degrees. Next to 9x. 9x means 9 into x. So 9 into x value is 12 degrees. So 9 12s, 108 degrees. And similarly, we find fourth angle, that is 13x. 13x means 13 into x. So 13 into 12 degrees, that is equal to 156 degrees. These are the measurement of angles of this quadrilateral. First angle measurement is 36 degrees. Measurement of the second angle is 60 degrees. Measurement of the third angle is 108 degrees. And measurement of the fourth angle is 156 degrees. Understood this question, my dear children? Finding the angles of a quadrilateral. Understood?
Yes, sir.
Shall we go to the next question? Shall we go to the next question?
Yes, sir.
Yes. Now come to the question number 2. Question number 2. If you have a textbook open, once see the textbook in the page number 146, question number 2. See this question number 2. If the diagonals of a parallelogram are equal, then show that it is a rectangle. We have to prove that if the diagonals of a parallelogram are equal. We know that actually in a parallelogram, diagonals are not equal. Diagonals of a parallelogram are not equal. Okay, just they bisect each other. Diagonals of a parallelogram bisect each other, but they are not equal. In case if the two diagonals of a parallelogram are equal, then we have to show that that parallelogram is a rectangle. Understood this point, my dear children? Now let us take a parallelogram. ABCD. This is a parallelogram. This is a rough diagram. Don't say that it looks like a rectangle, sir. Don't say like this. This is only a rough diagram. We have taken a parallelogram ABCD. Okay, we have taken a parallelogram ABCD to show this statement. Come to the solution part. Come to the solution part. First, we have taken a parallelogram ABCD. First of all, we have taken a parallelogram ABCD. What is the condition given here? Diagonals of this parallelogram are equal. Yes or no? In this parallelogram, diagonals are equal. That is given to us. What is given here? We have to read the question carefully. You have to read the question carefully and understand it well. So given that AC is equal to BD, what is meant by AC? It is diagonal. AC is one diagonal. What is BD in this parallelogram? BD is another diagonal. These two diagonals are equal. We are given that the measurements of these two diagonals are equal. Understood this is second step, my dear children? Understood this one? Now we have to show that the parallelogram ABCD is a rectangle. We have to prove that this parallelogram ABCD is a rectangle if the diagonals of a parallelogram are equal. If the diagonals of a parallelogram are equal, we have to show that this parallelogram is a rectangle. This is a statement to be proved. Okay, my children. Right. To show that ABCD is a rectangle, we are going to show that ABCD is a rectangle. Then we have to prove that one of its interior angles is a right angle. Yes or no, my children? In a parallelogram, if one angle is a right angle, then that parallelogram becomes a rectangle. In the concepts of exercise 8.1, we have discussed this point also. If any angle of a parallelogram is a right angle, then that parallelogram becomes a rectangle. We use this property. We use this property to show the statement. Okay, right. Come to this part, proof. Come to this part, proof. In triangle ABC and triangle BAD. In triangle ABC and triangle BAD. Here ABC and BAD. We have taken these two triangles. Observe these two triangles carefully. In these two triangles, which parts are equal? Can you tell me? In the triangle ABC, in triangle ABC and triangle ABD. Can you tell me which parts of, you know, this is a parallelogram. So this side equal to this side. AB is equal to CD. Why these two sides are equal? Tell me. These two sides are equal. Why these two sides are equal? AB is equal to CD. Can you tell me the reason?
So because they are parallel.
They are not only parallel, they are opposite sides of the parallelogram. They are opposite sides of the parallelogram. Similarly, AD, this AD equal to BC. Yes or no? What is the reason? Same reason. Same reason. These two sides are opposite sides of this parallelogram. Yes or no? AB and CD are opposite sides of this parallelogram. So they are parallel and also equal. Similarly, BC and AD, these two also a pair of opposite sides of this parallelogram. So they are parallel and also equal. And any more parts in these two triangles? See here AB. AB is equal to, see here. In these two triangles, we had to compare the parts of these two triangles. Okay, let us compare the parts of these two triangles. BC is equal to BA. BC is equal to BA. Sorry, BA is equal to BA. It is print mistake. BC is equal to BA. Here, print mistake. I will rectify this one. I will rectify this one later. BC is equal to BA. It is not a common print mistake. I will rectify it later. Next, AC is equal
Sir, the
to
both is common, sir.
AB.
Sir,
BC is equal to AB is equal to BA. This is a correct sentence.
okay, sir.
This is a correct sentence. I will rectify this sentence when I'm posting this PPT in the Google Classroom. I will rectify this sentence. Actually, here we have to write AB is equal to BA. See here, first two letters in triangle ABC, triangle BAD. Okay, what are the first two letters in this three letters AB? What are the first two letters here? BA. So you have to write AB is equal to BA. It is common side. Okay. Next, AC is equal to BD, not AD here also. AC, not AC. BC is equal to AD. BC is equal to AD. Yes or no? Here also print mistake. BC is equal to AD. BC is equal to AD. Here also print mistake. I will rectify it. Opposite sides of parallelogram. Here BC, we have chosen BC and AD are opposite sides of this parallelogram. Print mistake, when I am typing these sentences, by mistake, I typed here AC, not AC. BC is equal to AD. Okay. I will rectify it and I will post it later. Next, common AC is equal to BD. It is given. It is already given that diagonals. Here AC is equal to BD. It is already given. So, in these two triangles, which are compared here, three sides in this first triangle are equal to corresponding three sides in the second triangle. By which criteria we can say that these two triangles are congruent? Can you tell me by which criteria? Just now I gave a hint also. Three sides in this first triangle are equal to the corresponding three sides in the second triangle. I am showing by laser pointer also. Which parts of these two triangles are compared here? Which parts of these two triangles are compared? Side, side and side. Yes or no? Side, side, side. In the first triangle are compared with the corresponding side, side, side in the second triangle. So by SSS congruency rule, by SSS congruency rule, the two triangles are congruent. Therefore, triangle ABC is congruent to triangle BAD by SSS congruency rule. Understood this point, my dear children? How we have shown these two triangles are congruent? Understood this point? Then angle A is equal to angle B. Angle A is equal to angle B because CPCT, by CPCT, corresponding parts of congruent triangles. Angle A is equal to angle B. Okay. Angle A is equal to angle B. Also, angle A plus angle B is equal to 180 degrees. Angle A plus angle B is equal to 180 degrees. Why? The sum of these two angles equal to 180 degrees because the sum of the angles, these two angles are same side of the transversal. The two angles are interior angles on the same side of the transversal. If you take AD and BC as parallel lines, AD and BC as parallel lines, and AB is a transversal. If you take AB is a transversal, then angle A and angle B. These two are interior angles on the same side of the transversal. That is why sum of these two angles is equal to 180 degrees. Understood this step, my dear children? Angle A plus angle B is equal to 180 degrees. Why these two angles are equal to 180 degrees? That implies 2 angle A is equal to 180 degrees. Because why 2 angle A? Because angle B is equal to angle A. Yes or no? Here we have shown by corresponding parts of congruent triangles. So therefore, 2 angle A is equal to 180 degrees. This implies angle A is equal to 90 degrees. That is equal to angle B. So we have shown that angle A is equal to 90 degrees and angle B also 90 degrees. Understood this point, my children? So what do you say here? Therefore, ABCD is a rectangle because we have shown that one angle. It is enough to show that one angle of a parallelogram is 90 degrees. Automatically, it becomes a rectangle. Hence proved. Okay, my children. Understood this one? Shall we go to the next question? Third question. Question number 3.
Yes, sir.
Yes. Now come to the question number 3. All of you keep your textbooks open. All of you keep your textbooks open nearby you. And see this question number 3. What is the question number 3 here? Show that if the diagonals of a quadrilateral bisect each other at right angles, then it is a rhombus. We have to show that if the diagonals of a quadrilateral bisect each other at right angles, then we have to show that then the quadrilateral becomes a rhombus. It is a rhombus. Understood this question, my dear children? Right. Now let us take a quadrilateral. In this quadrilateral ABCD, don't say this quadrilateral looks like a rhombus. It is a rough diagram. You can draw a rough diagram. ABCD is a quadrilateral in which the diagonals AC and BD are perpendicular to each other and they are bisecting each other. Understood this point, my dear children? This is a given data for us. Then we have to show that this quadrilateral is a rhombus. Now come to the solution. Part. Let ABCD be a quadrilateral. We have taken a quadrilateral ABCD whose diagonals bisect each other at right angles. According to the given condition, we have taken a quadrilateral with diagonals bisect each other at right angles. Okay, at least we have to draw a rough diagram and write the given data at least. Then you get at least half mark. Okay, you have to draw a rough diagram for the given question. Whatever the question is related to geometry, you must draw a rough diagram. No need to ask you for every question, sir, should we draw a rough diagram for this question like this? Don't ask for every question in the geometry. Whatever the question related to geometry, you should draw a rough diagram, pictorial representation. It means you have understood the question clearly, and you represented that data pictorially. That shows that if you draw a rough diagram, then it shows your ability of understanding the question. Okay. Now what is given here? Given that OA is equal to OC. Previously I told you they are bisecting each other. So at O, it is a midpoint of AC. So AO length equal to OC length. Similarly, DO length is equal to BO. because they are bisecting each other. OB is equal to OD, and angle AOB is equal to angle BOC. That is equal to angle COCD, that is equal to angle ODA. If you take all these four angles around this point O, angle AOB, angle BOC, angle COD, and angle DOA. All these four angles around this point O, each angle measures 90 degrees. Understood this point, my dear children? Right. Now we have to show that when the rhombus, what is properties of rhombus? The diagonals of a quadrilateral bisect each other at right angles, then it is a rhombus. It is to be proved. We have to show that the diagonals of a quadrilateral bisect each other at right angles, then it is a rhombus. So we are going to show that this quadrilateral is a rhombus. For that, let us see how to prove this statement. That is, we have to prove that ABCD is a parallelogram, and AB is equal to BC is equal to CD is equal to AD. So there are two parts are involved. The first part is we have to prove that ABCD is a parallelogram, and the second part we have to prove that all the sides of this quadrilateral are equal. There are two parts involved in this question. Okay. Next, proof. Come to the part. Proof. Now let us take triangle AOB and triangle COB. Triangle AOB and triangle COB. In these two triangles, we compare the corresponding parts. Previously, I told you here OA is equal to OC, and OB is equal to OD. Yes or no, my children? Here we are taking these two triangles AOB triangle and COB triangle. Which parts of these two triangles are equal? Can you observe and tell me which parts of this triangle are equal? Yes, OA is equal to OC. It is given because they are bisecting. That is why we have written this statement. OA is equal to OC. Angle AOB is equal to angle COB. Angle AOB is equal to angle COB. Because here 90 degrees, this is also not a correct statement. Angle AOB is equal to angle COB 90 degrees because they are bisecting each other at right angles. Yes or no? So I will correct this statement also. They are bisecting each other at right angles. That is 90 degrees. Okay. OB is equal to OB. It is a common side. In these two triangles, we have compared. Which parts of these two triangles are compared? Side, angle, side. In one triangle are equal to the corresponding side, angle, side of the second triangle. Which congruency criteria we are using here? Yes, yes. Yes or no? Therefore, triangle AOB is congruent to triangle COB by SAS congruency rule. These two triangles are congruent. Understood this part, my dear children? We have proved that these two triangles are congruent. Thus, AB is equal to BC. So, AB is equal to BC by corresponding parts of congruent triangles. AB is equal to BC. We have proved these two sides are equal. Okay. Similarly, we can prove that BC is equal to CD. CD is equal to AD. AD is equal to AB. Like this, we can prove that these sides are also equal. Means all the sides of this quadrilateral are equal. Okay, my children. Therefore, AB is equal to BC is equal to CD is equal to AD. Similarly, we can prove that BC is equal to CD, CD is equal to AD, AD is equal to AB. Therefore, AB is equal to BC is equal to CD is equal to AD. So, we have proved that all the sides of this quadrilateral are equal. They are equal. So, we have proved the first part of that statement. Opposite sides of a quadrilateral are equal. Hence, ABCD is a parallelogram. We have proved that it is a parallelogram. Moreover, we have proved all the sides are also equal. Opposite sides of quadrilateral are equal. Hence, ABCD, the quadrilateral ABCD is a parallelogram, and moreover, it is a rhombus. Yes or no? ABCD is a rhombus. We have proved both parts at a time. We have proved it is a parallelogram, and moreover all the sides are equal. Therefore, ABCD is a rhombus as it is a parallelogram whose diagonals intersect at right angles. Hence, we have proved the given statement. Okay, my children. Understood this one? Now the time is 10 past 30. 10 past 30. So I'm not explaining the fourth question in this video, in this PPT. Please observe that PPT. I will post this PPT in the Google Classroom. Okay, my children. Now time is very less time. We have less time only. So I will post this PPT in the form of PDF in the Google Classroom. Please find out this PPT also in the Google Classroom, and after that write your mathematics classwork notes and submit. Don't ignore. I'm posting the classwork notes also clearly. Okay. Understood this point, my dear children? Now the time is 10 past 29 minutes. Now you can leave the meeting. Take rest. Take care of your health, my dear children. Stay at home. Stay safe. And submit your classwork notes.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.